Hello. In this video, I'd like to show you how to calculate the rate of change from a story. And in this case, it's a story about the growth of a tree that you planted in your yard. And this story gives you two pieces of information that we can use to calculate the growth rate in feet per year. And the first one is here that 3 years after you planted it, it was 15 feet tall. And the second piece of information is that 10 years after you planted it, it was 36 feet tall. So we want to use those two pieces of information to calculate the growth rate in feet per year. And one thing that I often see people do when they calculate a problem like this is they'll latch on to one of these pieces of information, 15 feet in 3 years, and they'll say, oh, 15 feet in 3 years is 5 feet per year. Or they'll work on just the second one, 36 feet, 10 years, and if they do 36 feet divided by 10 years, they get a different growth rate of 3.6 feet per year. And then they start to get confused. They think, well, which one is it? Which one is the correct answer? And it turns out that neither of these is the correct answer. And the thing that's complicating this situation is that in this case, you planted a tree and it must not have been planted from a seed. Its starting height must not have been 0. It must have had some height to begin with that's causing these numbers to be a little bit off. So after 3 years, it didn't necessarily grow 15 feet. It grew to 15 feet from wherever it started. So in situations like this, you can't just do a height divided by a year. What you need to do instead is you need to look at how the height changes as the years go by. And so what I often suggest on a problem like this is let's make a little data table. If we have a problem like this, let's make a data table and let's say we've got years and height in feet. And that marker seems to be dying, so let's switch up to a different one. And I can see that after 3 years, it was 15 feet tall. And after 10 years, it was 36 feet tall. So let's use this to see how much the height changes and how many years it takes to make that change. So I can see from here to here, the tree grows from 15 feet tall to 36 feet tall, which is an increase of 21 feet. And it grows those 21 feet from 3 years to 10 years, or an increase of time of 7 years. So if it grows 21 feet in 7 years, I can just get my growth rate in feet per year. 21 feet divided by 7 years gives me 3 feet per year. 3 feet per year. And we can kind of confirm this if I make an even bigger data table. If I have a data table that looks more like this, starting at year 0, going to year 10, I can see after 3 years it's 15 feet tall. After 10 years it's 36 feet tall. If I just add 3 feet per year, 15, 18, 21, 24, just continue to add 3 feet per year, 27, 30, 33, and finally 36. So it works out. Adding 3 feet per year makes those two times match our story. If I were to back up a year, back up 3 feet, that takes me down to 12. Back up a year takes me down to 9 feet, and back up a year takes me down to 6 feet. And so there it is. It turns out that when we planted that tree, it must have been 6 feet tall, assuming that it was growing at a constant rate. So that's why we can't just take 15 feet divided by 3 to get a growth rate. We have to look at how the height changes as the years change. Let me show you one more if you are interested. Here's another one that you can try. This one is about water being drained from a pool. So if you'd like to give this one a try, you can go ahead and pause it, see if you can get the answer. I'll show you my answer in just a moment. All right, so on this one, if I do the same thing I did before, if I make a data table, gallons of water still in the pool, as the hours go by. Again, you can't just do 22,000 divided by 4. You have to look to see how the numbers are changing. And so the numbers are decreasing as time goes by. So I can see that the pool loses 2,250 gallons. Oops, and I wrote 3 years. That should be 3 hours. 3 hours. And so if I do negative 2,250 gallons divided by 3 hours, we're losing 750 gallons per hour. So that's the rate of change in this case, where we're draining water from the pool and the amount of water is decreasing as each hour goes by. I hope this helps, and good luck.